All right, if you've spent any time with C++, you've definitely heard people talk about the rules of 3, 5, and 0. They can sound a little intimidating, right? But honestly, they are absolutely key to writing safe, efficient code. So in this explainer, we're going to pull back the curtain and demystify these rules once and for all.
Here's how we're going to do it. First, we'll tackle the fundamental problem that every C++ developer has to deal with: managing resources. Then, we'll walk through the history of how we've solved it, starting with the classic rule of 3, moving to its modern upgrade, the rule of 5, and finally landing on what should be everyone's goal today, the rule of 0.
So what is the big deal with resource management in C++ anyway? Well, it all boils down to being in control of things like memory, or open files, or network sockets. And right at the core of C++'s philosophy for handling this is a really, really powerful principle.
It's a mouthful, but it's called RAII. Resource acquisition is initialization. The idea behind it is actually simple and kind of brilliant. You tie the lifetime of a resource, like a block of memory, directly to the lifetime of an object. You grab the resource when the object is created in its constructor, and you release it automatically when the object is destroyed in its destructor. This whole automatic cleanup magic is powered by a handful of special functions the compiler can write for you.
And here they are. These are often called the Big Five. They are the behind-the-scenes machinery that controls an object's entire life, how it's destroyed, how it's copied, and, since C++11, how it's moved. Now here's the kicker. If you don't write these yourself, a lot of the time the compiler just says, "Hey, I got this," and generates a default version for you. But this is where things can get really, really dangerous. Because when you step in and start managing resources yourself, I'm talking raw pointers, manual memory allocation, relying on what the compiler does by default can go horribly wrong. In fact, trusting the defaults in that situation is pretty much a recipe for disaster.
This exact problem led to the very first major guideline for C++ programmers. So let's hop in a time machine and go back to the world before 2011 to look at the classic solution, the rule of 3.
The rule of 3 goes all the way back to 1991, and it was created to stop a super common and very nasty bug. The rule itself is simple. If your class needs a custom version of any one of these three, the destructor, the copy constructor, or the copy assignment operator, then you almost certainly need to write all three of them yourself.
So what's the bug? Well, it comes down to the difference between a shallow copy and a deep copy. See, the compiler's default behavior is to just do a shallow copy. If you have a pointer, it just copies the pointer's address. So now you have two different objects pointing to the exact same piece of memory. But what you usually want is a deep copy, where you actually allocate a whole new chunk of memory and copy the data over.
And this is the catastrophe that happens because of that shallow copy. The first object goes out of scope, its destructor runs, and it frees the memory. Great. But now the second object's pointer is pointing to garbage. And when that object gets destroyed, it tries to free that same memory a second time. That's called a double free, and it's a one-way ticket to crashing your program.
But hey, C++ doesn't sit still. The language evolved and the rules evolved right along with it. The launch of the C++11 standard brought a massive performance boost that really changed the game.
Yep, in 2011, C++11 gave us move semantics. This was a brilliant optimization that lets you efficiently transfer a resource from one object to another without having to do a slow, expensive copy. It's less like cloning a resource and more like, well, stealing it from an object that doesn't need it anymore. It's way, way faster.
And this powerful new feature led directly to the rule of 5. It's pretty much a straightforward expansion. The rule says if you're managing a resource yourself and you define any of the 5 special member functions, you should probably take care of all 5, either by defining them or by explicitly deleting them.
Now here's the crucial thing to understand. If you follow the old rule of 3, but you just ignore the 2 new move operations, your code will probably still work. The compiler will just shrug and fall back to the slow, old copy operations. But, as this great quote from the Sonar blog points out, you're missing a huge opportunity to make your code faster. You are just leaving performance on the table.
Okay, let's be real. Implementing all 5 of those special functions correctly, it's tedious and it is so easy to mess up. That complexity is what pushed the C++ community to find a much cleaner, more elegant, and more modern way of thinking about this. And this fantastic line from R. Martinho Fernandez perfectly captures the philosophy behind what has become the ultimate goal in modern C++.
This is the rule of 0, and it's beautiful.
It says that the best case, the thing you should always be aiming for, is to write classes that have 0 custom resource management functions. Your classes that handle business logic shouldn't have to worry about memory pointers and file handles at all.
So how do you do that? How do you achieve this Zen-like state of no code? You delegate. Instead of doing the dirty work yourself, you use specialized classes from the standard library that are built for resource management. Things like smart pointers and standard containers. These things are written by experts, and they already follow the rule of 5 perfectly, so you don't have to.
Okay, so we've got 3, 5, and 0. With all these rules floating around, how in the world do you know which one to use? Well, let's put it all together into a really simple guide.
Honestly, it's pretty straightforward. Your default setting, your first thought should always be to aim for the rule of 0. Can you use a standard library tool to manage the resource for you? If the answer is yes, do it. It's only in those rare cases where you're writing some low-level class that has to manage a raw resource itself that you fall back to the rule of 5. And, of course, if you're stuck maintaining a really old code base, then the rule of 3 is your guide.
And hey, for all the experts out there, there's even a little bonus rule that people sometimes call the rule of 6. This is a special case that applies to polymorphic base classes. The short version is, when you give a class a virtual destructor, which you should, it can mess with the compiler's ability to generate move operations. So, the best practice is to just explicitly default the other 5 to make sure everything works as expected. So let's wrap this all up in a neat little package. The rule of 0 is your goal. It's the default. Delegate ownership. The rule of 5 is for those rare times you're writing a resource-owning class in modern C++. And the rule of 3 is your guide for legacy pre-C++ 11 code. Simple as that.
When you step back and look at it, the real takeaway here is that this whole evolution from 3 to 5 to 0, it's a story of progress. It's about a huge shift in the philosophy of C++, pushing all of us to write code that's not just safer, but also cleaner and way more expressive, all by writing less code and letting the standard library do the heavy lifting. Thanks for watching.